Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy. We are continuing our video series. This is the sixth video in the series and we're looking at the fifth index laws on fractions and powers. Let's get right into it and you'll see what I'm talking about. This is the law here. Don't freak out, I'm going to unpack that for you. So what it's basically saying is if I have a fraction and that fraction gets raised to a power of m, I can simplify that by getting rid of the brackets. And what happens is that the numerator and the denominator both get that power. It's a little bit like an extension of index law 3, which said also about powers. Anything inside the brackets gets the power that's outside the brackets. Well, that's basically what we're saying here. And in this case, it's the top and the bottom of the fraction. You'll notice here we've got this little expression here as well, that b cannot be equal to 0. And the reason for that is if we have a 0 on the bottom of a fraction, well, you can't divide anything by 0. We talked about that in our last video, so I'm not going to labour the point again today. Let's do some bit of an understanding about why this rule works. So let's first of all think about our rules about how we multiply a fraction by a fraction. So I'm going to do an easy one, a half of a half, or a half multiplied by a half. Now our rule is that we multiply the numerators, that's the tops of the fractions, by each other, and then I multiply the denominators, or the bottoms of the fractions, by each other. And then, if I can, I simplify the fraction. So let's do that. So the tops of the fractions were 1s, 1 times 1. The bottoms of the fractions, the denominators, were 2s, so that's going to be 2 times 2. You notice how I actually have joined these two fractions together to make one big fraction. And that's what we do when we're multiplying two fractions together. So now I can simplify the top. 1 times 1 makes 1, 2 times 2 makes 4. I've got half of a half makes a quarter. And that makes sense because if I have half of a cake and I cut that in half, half of that cake, half of the cake is a quarter of the cake. And that's what multiplying is. We're actually finding a fraction of a fraction. Okay, so let's now see how that relates to index laws. Well, you remember that index laws is all about multiplying something by itself. And in this video, we actually are talking about raising fractions to indices. So in this case, we've actually done a half squared. So anything multiplied by itself once is called squaring it. So half times a half could also be written as a half squared. Okay, that's a nice simple way of writing it. Now, remember our rule says that anything inside brackets, everything inside the brackets get the power. 1 gets squared, 2 gets squared. Okay, I think you see where I'm going with this. Up here, we're multiplying 1 by itself and 2 by itself here. So 1 squared is 1, 2 squared is 4. So the rule works. Okay, so rather than having to write, let's say this was a power of 10. Rather than writing out a half times 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 a half and so on and so on 10 times and then multiplying all the tops 10 times and then all the bottoms 10 times, I can simply just rewrite that as 1 squared over 2 squared. And obviously if they're numbers, I do the answer. Let's look at some worked examples. Okay, so this one here is a fraction that's part letters, part numbers. So I'm going to start by stating the rule. I've got a divided by a 3, or a over 3 is another way of expressing that, and it's raised to the power of 3. So I could multiply that by itself 3 times, but my rule says I'm simply going to raise the top to the power of 3 and the bottom to the power of 3. So that becomes a cubed divided by 3 cubed. And if I've got some reasonably simple numbers down the bottom, I should make an attempt to simplify that further and actually work it out, which is going to be a to the power of 3 divided by 27. Let's look at another worked example. I've made this a little bit harder. We've got some numbers inside the brackets. We've got some negatives. There's a few things going on here. Let's unpack that. So once again, we're going to write our rule down. It says the top gets raised to the power of 3 and the bottom gets raised to the power of 3 and everything in the brackets. So notice here I've got this -4 and I've got this +2. So this part here, this is going to get a power of 3. That's going to get a power of 3 as well. This here, I'm going to apply my rule of multiplying the powers. So I'm actually combining here index law 3 with this fifth index law here. So this is going to get a power of 5. This one here is going to get a power of 15. Sorry, a power of 6 up the top and a power of 15 on the bottom, 2 times 3. Okay, so see here, I've expanded that out. I've now got a negative 4 to the power of 3 and a 2 to the power of 3. So this here is going to simplify to 6. That's going to simplify to 15. 2 to the power of 3 is pretty straightforward. It's going to simplify to the number 8. 2 times 2 makes 4 times 2 again makes 8. This bit here, it's very tempting to just put that on the calculator and type in negative 4, press your raising it to the power of 3 button. What your calculator is going to do is it's going to give you a negative answer. Now in this case, it will be negative. However, if this was a power of 4, for example, it would still give me a negative answer, no matter what that power is, whether it's power of 2, power of 3, 4, 5, it's always going to give me a negative answer because your calculator is going to multiply your result by negative 1. You need to be really careful with that. I would say if you're going to put negative 4 to the power of 3 in your calculator, actually put negative 4 in brackets in your calculator and raise that to the power of 3 first to get the correct answer. Here's what I'm talking about. It seems like I'm rambling for no reason, but I have a purpose. Negative 4 times negative 4 is positive 16. A negative times a negative makes a positive. Multiply positive 16 by negative 4 again, you get negative 64. So each time you multiply it by negative 4, it goes from negative to positive to negative to positive. So that's why it's really important that you put it in brackets so that your calculator doesn't get confused. And it will get confused, believe me. So now what I've got is, I've now put this negative out the front here. Doesn't matter if it's here or if it's here. It's the same thing. So negative 64 over 8. I can actually simplify this. 8 divides into 64 8 times, because 8 times 8 makes 64. So it's actually going to be negative 8 K6 over J15. You might be wondering, why doesn't the 8 go out the front over here and then the K's and the J's sit out to the side? And you could also write it like that as well. The important thing to note though is that the 8 does not go on the denominator. That would mean an eighth, 1 over 8, which is not correct. It's 8 over 1. Okay, we don't normally write the 1 when we write a fraction or a number over 1 because anything divided by 1 is just that thing. So 8 divided by 1 is just 8. That's why the 1 disappears. Okay, we're going to do another quick worked example. This time I've got everything inside brackets. We've got a fraction happening again. It's all raised to the power of 3. So we're going to write that rule out. You'll notice here I've got a number 5 out the front just to be tricky. You might not have even seen that there. It kind of fades in with the background. But 5 is not raised to the power of 3. It's not part of what's going on inside these brackets. So it's going to sit out the front and it's going to be multiplied by what's going on in here. So now I've got the x to the power of 7. It gets the power of 3. Y to the power of 2 gets the power of 3. X to the power of 3 gets the power of 3. Y to the power of 10 gets the power of 3. So everything in the brackets is raised to the power. So that means we're all going to be multiplying. So 7 times 3 makes 21. 2 times 3 makes 6. 3 times 3 makes 9. 10 times 3 makes 30. And so you'll notice here that the 5 is sitting out the front because the 5 was multiplied by everything in the brackets. I could also rewrite that like this. 5x to the 21. y6 divided by that. And so either of these answers, both are correct. They are both the same thing. It's a good idea to just familiarise yourself with seeing that presented two different ways. Because what this means over here is 5 times this whole fraction. And what this means over here is 5 is part of the top of the fraction, the numerators. Okay, and we are on to our final worked example. We're going to be multiplying fractions by fractions. Okay, it gets a little exciting here. Okay, these are not in half by half anymore. The same rules apply, okay, as though they were numbers. So we're going to multiply, we're going to expand those brackets out first, then we'll times everything across the top, everything across the bottom. Okay, so it looks a bit yuck. Just work with me here. So I've just repeated the question here, exactly as it is there. So now what I'm going to do is everything in these brackets gets raised to the power of 5s. So 2 times 5, 4 times 5, 3 times 5. So that's that first fraction, brackets removed. Over here you'll notice it's only the numerator that's got the power of 4. Over here it's the whole fraction. Here it's just the numerator. So be really careful to make sure where those powers are applying. Questions will always do this to you just to check if you're checking your work properly. So the m to the power of 3, it gets the power. The squared gets the power. This n squared on the bottom does not have any change to it whatsoever. So now now that we've got these workings here, let's work it out. So we've now got the 2 times 5 makes 10, 4 times 5 makes 20, 3 times 5 makes 15, 3 times 4 makes 12, 2 times 4 makes 8. So now we've got a fraction times a fraction. Now remember when we did a half times a half, the tops got timesed, the bottoms got timesed. And so it's the same here. Everything across here gets timesed, everything across here gets multiplied as well. Now, this is where it's like one of those combination laws. Now you've got to remember index law 1, where we add the powers. Okay, so now I've got 2 of the same bases, m's, 10 plus 12 makes 22. There's only one lot of n's at the top and one lot of p, so they don't change. And a p on the bottom and the n on the bottom, they don't change either. They're just now smooshed together. What I've done is join the two fractions and made one big fraction. And now I'm going to bring in index law 2, which means because I've got division, I'm going to subtract some powers. So nothing's going to change about my m to the power of 22 because there's no m's on the bottom. But with the n's, there's n's on the tops and the bottom, and there's p's on the top and the bottom. So we've got to simplify those a little bit further. So now what I've got here, the m22 is not going to change. N to the power of 20, take away n to the power of 2, makes 18. And p, 8, take away 15, well, 8 take away 15 is negative 7. So now I no longer have a fraction. I've just got one nice, simple term. It's amazing when you think about where we started with all of this going on, and especially once we expanded those brackets, it looked huge, but it simply simplified to something nice and neat. There are further steps that we could do with this. We're going to talk about that in one of our future videos when we talk about negative powers, but we'll leave it there today. Hopefully you found this video super helpful. If you did, why not tell us in the comments? You can also like and subscribe, share the video with a friend, or even join us on Facebook and Instagram. The more the merrier. And if you've got any questions whatsoever, please contact us at mcclutchymaths@yahoo.com. Please don't put it in the comments, especially talking about indices. That's going to be really hard to explain stuff in the comments. Best in an email. Well, thank you so much for watching. I'm Natalie McClutchy. Have a wonderful day.